Hello?
If okay, I will put. So Yusuf, now we
Yep.
are back. So you can please start.
Okay, so
Sorry, both to you and to John for the delay,
yeah,
but
no
it's
problems.
very interesting discussion, and they didn't want to interrupt. So please,
Yeah,
Yusuf, the stage is yours.
thank you. I hope you can see the right screen, the presenter screen.
No, we still see the
Still,
We are seeing the
so
slide screen, not the presenting screen.
now I have changed it. It should be different, huh? Otherwise, I have to disconnect the second screen.
Maybe try to share another screen.
So I have changed it, but it's still the same.
I think you need to choose share the full window, not only the screen.
That can be not.
So try it again. So I have disconnected the second screen, so we shouldn't have this issue anymore. So now it's the right one, right? Because
no.
I only have one screen.
We still see the other one, but okay.
Still?
Yeah.
That's weird. So if I'm now, can you see this next slide when I'm moving?
No.
Maybe do I have to open the PDF? Am I the first one who has this issue?
Actually,
So now I have opened as a PDF. Can you see it now?
Yes.
Now it's right? It's
Yes.
visible. Okay, thank you. So it has to be a nice coffee there. And I know from my experience that in such events where you have a lot of presenters and presentations going on, like back to back, delays are often the case. So no problems at all. Before I start, a big thank you for the invitation. Unfortunately, I'm not able to attend physically, but thankfully we can present virtually. So who am I? I am Yusuf Yilmaz. I am working for the German Institute for Standardization, which is also called DIN, as a project manager for research projects. And today I'm going to have a presentation about the role of terminology standardization in the quality assurance domain. So before I start, some background information about DIN. DIN is a neutral platform for standardization in Germany and also on the international scale. DIN is a private organization with more than 36,000 experts from different sources like industry, research, consumer protection, but also public sector. And DIN has 69 committees with a diverse topics ranging from acoustics to water management. And DIN has 528 staff members with more than 3,400 core members. So in Germany, 34,830 standards are making up the German body of German standards, as of 2021. And one of the most successful international standardization examples is the ISO container or the ISO 668. And every year, 250 million of such ISO containers are traveling the world. And that shows the great impact of international standardization. Another good example is the ISO 9001, which is the quality management standard, which companies use to increase their efficiency and quality and also lower their costs. So we can say that everyone benefits from standards because they enhance efficiency and quality, they promote trade, and they make products safe and environmentally friendly. So the consumers, on the other hand, they can benefit from plenty of reasons. Just to name some of them, the compatibility, because a lot of companies, technological companies, are producing different kind of components, and with standards, these components can fit and function together. Also, we have the durability aspect, because you can set requirements in these standards, so the product itself gets more durable. Also, standards make products more safe, and also you can save a lot of resources because you know exactly what the standard in the industry is, so you know exactly what to produce. So to the economic benefits, as I said, standards are saving a lot of costs because you don't have to spend too much money on research and development and also production costs. You can take advantage of the great pool of expert knowledge, because DIN itself, like alone, has 36,000 experts, as I said, and that's just the national body of Germany. So you can imagine that there is a huge pool of knowledge, and you can gain access to this and also expand your own network. Also, the trade benefits from standards because they facilitate market access and also help this to dismantle barriers to trade. And lastly, if a company can show that its products are complying to some standards, this is automatically a sign of quality and trust for the consumer, which will inevitably hire. Sorry?
Sorry to interrupt. Have you moved the slide? Because we are always seeing the first page of the title page of the slide.
Why is no one telling me? I'm just going through this. That's weird because no.
That's also weird for us, but it's the first time we see such difficulties in scrolling down the slides.
So
maybe in the worst case we can use PDF. Yeah, in the worst case. Are you moving around?
I am.
We are not seeing it. We are not seeing it.
And now I see the problem. I have to switch it on the AirMeet page.
Yes, it is moving.
That's the first time I have this. Should I start new or just show the slides which I have presented until now?
We can quickly brief in the slides onto the present slide.
Yeah, so these were the slides. Okay, if you go on. Okay. All right, then I will go on. Sorry for this problem. I never had this before. So economic benefits. So I was here. So we have also a lot of economic benefits. And the last one was the quality attribute, because when a company can show that its products are complying to some standards, they automatically show that this product has a high level of quality and also enhances customer trust. So now I have to change it here. Yeah. So to quantify these benefits, a German researcher has found out that the German industry alone is saving 17 billion euros every year thanks to standardization. Next slide. Yeah. So DIN is also active in research projects. As I said, I'm project manager in research projects. DIN is participating in several research projects, but national and also European level. And currently we are active in more than 20 ongoing projects from Horizon 2020 and also Horizon Europe. And these projects, we are identifying the potential for standardization on the basis of project results. That means that we are closely keeping track of the project status and the results of it. And according to that, we are setting standardization strategies, and we implement those strategies by initiating our own standardization activities. For example, the creation of a CEN workshop agreement or the CWA. So one of those research projects, European research projects, is ZDMP, the Zero Defects Manufacturing Platform. The aim of this European project is to establish and develop a digital platform for connected smart factories for achieving excellence in manufacturing through zero defect processes and products. It's a quite a big consortium with 33 partners all around Europe, and it goes for 4 years, and it should end this December, but it was extended for 6 more months. So, and it received total fundings of 60 million euros of the European Commission. So, before I move on with what we have done in ZDMP, I would like to talk about the connection between standards and terminology and ontologies. I'm not an expert on ontologies, but as far as I have understood, terminologies are common language, which enable efficient communication between different persons and to avoid misunderstandings. So this alone is a standard. Also, ontologies enable the communication between computers and machines. So ontologies provide an opportunity to tackle the obstacles or interoperability obstacles in digital manufacturing. And as I said, one of the key benefits of standards is the interoperability. And also ontologies are very important enablers for communication in Industry 4.0. Yeah. So now today's world, a lot of processes and products and technologies are interacting with each other in very different ways. And ZDM is a very important principle. And in ZDMP, we have identified that there is no specific terminology standard for ZDM. So that's why we have created this CWA 17918, which is called ZDM term, although it was changed to ZDM vocabulary afterwards. But I think the title ZDM term fits better, so that's why I have kept it this way. We have our scope was to define terms for ZDM in digital manufacturing. And in this work, 11 organizations were involved, mainly from the European project ZDMP and also the sister project Quality. We have submitted this work this month, so it's quite fresh and new. And lastly, I would like to draw your attention to the public consultation of this draft, CWA, because as you can see on the right side, we have posted this CWA on the CEN website, and I can share this screen, share the website and the link. Yeah, there it is. So you're all welcome to send your comments to me, to my email address, as you can see, until the 14th of October. Until this deadline, we will gather all comments or remarks, and until that, we will consider all of them. We will discuss about them, and after that, we will publish the final version of this CWA, also on the CEN website for free, because the costs will be covered by the ZDMP budget. Yes. So we had some problems, but I'm at the end. Thank you for your attention. And if there are any questions, I am pleased to answer them.
So thank you, Yusuf, for the interesting presentation. Are there any questions from the audience?
So are you going to or to start this working group?
Sorry, I can't.
Using the WA that Yusuf posed in the group on the iOS.
Yeah, just to listen.
So, Yusuf, thank you very much for your presentation.
You're welcome. You're welcome. Sorry for the problems and technical issues.
No problem. Sorry for the delay. John,
No problem.
the floor is yours for your presentation.
Okay, I end my. Okay, I have ended it.
Yusuf, if you want, you can mute yourself.
Okay.
So, John, the floor is yours.
Thank you, Fivos. I just need a couple of moments to share my slides. I hope you can see my slides.
Yes, we can see them.
Thank you very much for the opportunity to speak in the formal ontologies community, especially on the topic whether, first of all, and why we should use, why and how we should use semantics and formal ontologies in the quite complex application of zero defects manufacturing. So today, what I would like to share with you is I'd like to start with some past experiences I have had. I'm coming from the industrial IoT community, rather I would say from the ontologist community, but I had some experiences, and that I will share with you the experiences we had from using ontologies in some Industry 4.0 applications. And then I will go on explaining what is the potential of semantics and ontologies in Industry 4.0, which in my opinion go far beyond the state of the art. Why it is a good idea to do this for the zero defects manufacturing space, but also what could be some challenges, some questions, and an adoption pathway, all of this for the consideration of our audience. Now, the topic of using ontologies in manufacturing is nothing new. I mean, if in the literature, in the Internet of Things literature, and in the digital manufacturing and industrial automation and industrial engineering literature, you will find the term ontology and also applications and examples during the last 10 or even 15 years. And what's the motivation here is that we are having a lot of data. When we start using digital data in Industry 4.0, we are having this thing which is called, many data sources, heterogeneous data sources, big data for short. And also, we've got a lot of different processes and systems which are defined different, and they operate differently, which means there is some heterogeneity, and the issue of integration and interoperability becomes challenging. So these are good motivations to use ontologies. Then when you start using ontologies and semantics, you see that it's quite a complex task because you need to model a lot of artifacts. So manufacturing systems, manufacturing resources, processes, supply chains, products, materials, and yes, there are some formal ontologies to do this, like IOF, International Ontology Foundry, but these are also still far from covering what you need for a fully fledged application. Now, experience number one, we did that in my company, by the way, net company, Intrasoft, an international company based on Luxembourg. We did that in one of our past projects. We used the Mimosa schemas and the Mimosa ontologies for the sheer reason of homogenizing diverse data sources in the context of asset management and predictive maintenance applications. So it was a common language for different sources, different systems to supply data and to help us work on the predictive maintenance problem. So it was, a sort of underuse of ontologies. We didn't have complex reasoning, but it worked well to bridge different sources, and you can read more information in the paper below. Of course, the potential is much more than bridging different sources and calculating some remaining useful life. for example, in predictive maintenance and in asset management, the criticality analysis is very important. And having a common language to denote defects, to denote problems in a maintenance, in an asset management application is very important, because you can actually do much more things, not only if you know that there's going to be a problem with the asset, but when you know what is the level of criticality of this problem. And this, you need a common language to identify what are the different levels of criticality, especially when you've got multiple assets from different sources in an application. And this is useful when you have, for example, different systems and you want to collaborate on asset management, or to take joint decisions, right, about how you're going to maintain different assets, what you're going to maintain first and next, and so on. Another example, and in this project it was also FIVOS involved, and he was doing the semantic work. So this is the Eureka project, and semantics are used as the common language to handle large-scale disruptions in manufacturing processes. Imagine, these disruptions we had during the beginnings of the COVID-19 pandemic, right? During the outbreak, we all know that supply chains and manufacturing processes were a mess. Some suppliers were simply not reachable. We needed alternative paths. And there, if you really want to be fast, and if you really want to exploit the merits of automation and Industry 4.0, you need a common language about products, about parts that will allow you to negotiate in the supply chain, to perform this smart matchmaking of demand and supply, because this is what was, solving the COVID equation in manufacturing was all about. And semantics can be a very good tool for doing this, having increased manufacturing resilience and addressing large-scale disruptions. Now, moving to the zero defects vision, which is actually the subject of this, the core subject of this talk. When we talk about zero defects vision, we do not talk just one way at looking at production quality or defects and so on. So you can imagine that the problem is orders of magnitude more complex than simply predictive maintenance we were discussing a couple of slides before, because you've got corrective techniques, preventive techniques, predictive techniques, and you need to combine them in order to make sure that no defect happens. So this is what zero defects is about, is a path to excellent process and product quality by combining defects at different levels, at different time scales. So you really need to combine different processes. You really need a common language for this. At the same time, you need to act fast, because in the zero defect paradigm, it is very essential not just to reduce the adverse effects of a defect, but actually to avoid it, to make sure that the defect or the production problem never happens. So you need a rich language, but at the same time, you need to be fast, and you need to be preventive, predictive, and sometimes corrective, all at the same time. So in this context, if we needed one language to ensure a common understanding of criticalities, in the zero defects, you understand that the benefit can be scaled up, because you need semantic interoperability at a larger scale. You need a common language about defects, about processes, about products, about meanings like the byproducts of defects, for example, the different wastes, energy waste, which is a very important, and also parameters that relate to circularity. So unless you've got a common language and common semantics and rich semantics to describe this, it's very difficult to achieve perfect automation and collaborative processes. So my take is, yes, it's a good idea to have semantics in ZDM. Now, I'd like also to talk about another thing which is relating to ZDM, because a lot of things there we are doing through machine learning, okay? Artificial intelligence. That's what we use, for example, to predict defects. And we have a lot of research papers proving and claiming that if you use semantic representations like knowledge graphs when you are doing machine learning, like predicting some defect or some asset problem, then you can achieve better explainability of the machine learning. And this will be becoming soon a regulatory requirement, especially in Europe, with the AI Act, the regulation of the Council of Europe. And this reinforces the idea of using semantics for ZDM and for processes which are more complex, but still they have to be explainable. So what do I suggest? Of course, we know a lot of projects that have developed ontologies, and it's quite complex. This is also our experience from Eureka. It's not a single ontology, but we can start from, we have a good starting point, like the IOF or the BFO ontologies, and then selecting the application-specific constructs or formal ontologies that can help you solve the problem at hand. For example, we've got a lot in the ZDM projects of the European Commission, like Z4Break. You can find there a lot of ontologies already developed. So maybe you can avoid developing something from scratch. And then because you've got different problems, you need to start ontology merging, ontology integration, mapping, alignment, and so on. And this is a data model that will be put in the decentralized data infrastructure that we need for the supply chain. We call this sometimes a data space recently. Of course, there need to be some pilot and testing the thing, because you really need to make sure that you get the automation benefits out of it. Otherwise, the complexity might not make perfect sense. Now, some thoughts for discussion. So some questions that you need to consider, explore, if you think of using ontologies for ZDM. One is, what is the modeling simplicity versus expressive power? Of course, we want more complex concepts. We need to model more complex concepts, but still in industrial applications, we need simplicity, we need speed, we need things that work, and we need things that scale. So this is a consideration, it's a trade-off. There is certainly some manufacturing, we know, all of us that we are in this space, it is a conservative industry, and we have to bear in mind that ontology is rather an advanced, IT and knowledge representation concept for a quite conservative industry. So there needs to be some discussion, some training, some cultivation, and some cultural shift to make this happen in factories. Now, speed is, of course, of the essence here. I don't know what are the recent benchmarks of ontology tools in detail, but bear in mind in this community that some industrial problems are really high speed, low latency problems. And there, we won't be able to succeed unless we have a low latency infrastructure. And finally, a thing which is our enemy is the lack of many validated and scalable deployments. And this can be a problem because in a conservative industry, you need to start with things that work and have a proven track record. So with these thoughts, I would like to end up to end this talk. And yes, if there are any questions, I'm really interested to know what questions do you have about the use of ontologies in Industry 4.0 in general and in zero defects manufacturing in particular.
So, John, thank you very much for your presentation. Please, the audience, any question to our presenter? It seems, John, there are no questions. You covered a lot of topics, and your presentation was very insightful. So thank you very much for your time.
Thank you, Fivos, and thanks to our audience. And I'll be also available anytime. Thank you. Bye.
Thank you very much. So now we're moving to the final presentation, which is given by Ariel.
Yes. Splash screen. Okay, thank you. So, yeah, how do I do this? I guess I use that speaker. Okay, okay, friends. This was a familiar audience.
Yeah.
Okay, but Fivos invited me to say something about IMF in 10 minutes. So let me try to find the key points. So first, this is an industry-driven project that actually exploits ontologies and semantic technology. And there's a history behind that, in the sense that it was started in a industry-funded project with industry participants. Then Equinor, a couple of years ago, adopted it and wanted to bring it further. And then also the Sirius Research Center, which I lead, is part of this team. And now we are approaching the standards, and we want to sort of take it out of the context in Norway that is currently developed within. So we want to deliver a manual with method and a technical specification. We want to deliver a recommended practice that can be referred to in contracts as information deliveries requirements. And we want to use the software that has been developed, and which I will not have a chance to show now in 10 minutes, as a basis for an open source community. This is so the nature of this project is that it is industrial, and that means the goal is to enable a transition to model-based documentation. I'll say a little bit about. I will come back to what we mean by models, but it's very important that we focus on the transition, and that means implementation in the real world, in real business processes. And it's driven by a field development project of Equinor. So it's not an R&D project. Scalable implementation is absolutely critical, and incremental. Do the transition incremental steps. And speaking to the ontology community, that means that there has to be an incremental increase in the degree of formalization. If you try to aim for too high, too early, it won't scale. Then focus on what sort of matters in industry, and then one key point, one important observation is that ontology designers and especially so in the academic setting will develop concepts, as many as possible with a fine-grained definitions as we want, and strive for clarity in that sense. But this is a complexity that is contrary to the natural tendency in the industry to converge towards as few alternatives as possible. So, and what you will then focus on is what we call types. So they could be seen as basic building blocks, but they are complex. They are much more complex than just a class. So one may wonder, if you look at all the ontologies that the academic communities have developed, why hasn't the industry done the same? And I think the reason is the industry focuses on types and not on classes and class hierarchies. Simply put, we have to sort of meet these words, and then it can be powerful. So from documents to models. So I like to sort of point to an important point. Documents are used as documentation. Every time you want to so in a real project, to exchange information either across the value chain or between disciplines or between applications, there will be some documentation. You will need some documentation, and this is very much various forms of documents. I mean, you can discuss how digital they are, but they are documents in nature. And the reason why they work is that they can be made by SMEs without a lot of training. That's just the natural way they would work. The precision is appropriate for the use, and the use is that they should be interpreted by specialists in that field. So you can presuppose a lot of background knowledge, and if there is a lack of precision, then the reader will compensate for that. And then the format of a document is application independent. It's very important. And in a large company, there is a complicated process of moving data between applications, which, I mean, we could call that a data pipeline or an ETL flow or something of that flavor. And document formats are easy to integrate. So if we want to complement with models, we need to tick off on these features. I mean, it's when you try to sell models, it's easy to tell what you can do with a model that you cannot do with a document, which is of course why we want to move to models. But you cannot implement it in the industry unless you can answer to these questions, and that means first SME must be able to make the model without sort of much help. That means that it has to be an engineering language. If it is a documentation language, it won't be used. It has to be a language that helps you to do good engineering. Second, the precision must be sufficiently high for what you want to do with machines. And that's where you need ontologies, and that's where you need all this power of semantic technology to achieve that. Format, if it's not application independent, also, I mean, it won't scale in an industry. It can scale in a company, but it's not in an industry. And it must be easy to include also in this data flow, and that means there has to be something very well thought through about identifiers. So I'm not going to, but this is IMF sort of aims to do all of this in one package. And then we have identified some key roles. So key role, the SME will do system modeling. The knowledge engineer will know about ontologies and all these nice things. The knowledge engineer will interpret the models from the engineer, which is a special discipline in itself. This data engineer will do ETL things, and there's also a huge need for integration, which is a special feature of IMF, which, I mean, is not yet really developed. But this is all important in a real project. That you, for instance, at the contractor site, you will integrate a lot of pieces of information from all the suppliers and put that into a coherent picture. And when you come to commissioning, you would like to to make smaller pieces again, but not the same pieces as you used previously. So not only to integrate, but also to split into new pieces. So okay, models. So these are object models. There are questions you need to be able to answer or when you talk about models, but I think one very important point is how do you refer to the objects? If you are an SME, in a Norwegian project, you would use a tag number, which is I can tell a lot about that, but one of the things we aim for is to offer something better. So instead of a tag, which is sort of made up front, we would point to an object by its position in a model. But still, this is a descriptor. It's not a proper identifier. It's a descriptor. It's a way to describe the object, identify the object through description in some sort of context. This knowledge engineer would use a strong identifier from semantic technology, not the same. The data engineer would use a proper identifier for the ETL process. And it's important to keep these apart. Okay, I need to speed up. Then my point is that IMF, to deliver this, is really not one language, it's a family of languages. And mechanisms to go from one language to another. So in terms of ontology, the mechanism would be interpretation. So the way that the ontology would be used is to formalize the interpretation of the system model, which we could initially define through usual first-order interpretations, which we formalize through some templates technology that we are developing. Okay, this is a figure that shows a bit of the larger picture. It's not possible for you to see, I think. But, okay, this is the project documentation that is we want to complement. Here would be the engineering registers where all the master data would lie. This is the models that we propose to make. They will use all standards and they will make use of ontologies and reference data and such things. We will generate the ontology. And we will have identification systems that can correlate and manage the mappings, put it that way. Okay. This figure shows what a type could look like. In the green, it is the concepts that you would take from an ontology, dictionary concepts, identifiers for classes, attributes. You will compose a type, and you will build up a library, because the reason for building up this type is to reuse it through a library. When it comes to the relations, we very much starting point is this 81346 standards that is based on aspects, different aspect views of systems. We build models by instantiating types. These are this type library. This is an instantiation, and this is a small piece of model. So yeah, and then we get the models which will have certain features. The one that is displayed here is that it shows clearly that you will have different breakdown structures whether you focus on the function or the physical part and the way it is built up physically and the location breakdown. But there are more relationships. But essentially, it's a very highly structured graph that we do. But we try to do that in a way that scales and that preserves patterns in a recursive way, so that we can sort of zoom in and out and view and access the model at the appropriate level of detail. So, okay. That was not 10 minutes, but I mean, the best. Nobody's perfect.
Thank you very much. Are there any questions?
That's one detail about the technology used to use term interpretation. So, you know, on the commons, we take the white papers, or where among the others,
Yeah.
we use the term knowledge management, translate the same meaning, translate the concepts or entities to mean knowledge engineering is best.
Yeah. So
So it's more than translation, interpretation.
and in my terms, interpretation will be one way of translating, but it's more. Interpretation is a term from logic.
Yeah.
So, but I mean, it is a mechanism of translation, surely. Yeah. Yes.
Thank you for the presentation. It was not clear to me if we are talking about document models or system models.
System models.
System models. But by the way, as you know probably, ISO AEC 81346 considers we can have also an aspect, a documentation aspect.
Yes.
And first, the object that is, I think, important and clearly said in the ISO AEC 81346 can be a physical one or an intellectual one. So document can be an object also. Or
Yeah.
An object. It is written in sound. So, and you could have a breakdown structure of the documentation and make also links.
Yeah. So this is we do that. So
Okay.
we have what we call a tag aspect, and the object there would use this tag doc link.
Because there is a great tradition in aerospace industry to handle tech data, technical data in a structural way with I1000D standard and according structures of documents and modular, and each populate a common database for the operator. And they can compose the different modules to produce documentation, which is structured documentation. Okay. So I think yes, and among the documents, there is graphical documents, NID, and so where you have symbols and to be interpreted also. Maybe according other standards, as standards or teaching.
Yeah.
And yes, we have seen that otherwise in the PCA library, I think, with XP and so on. And textual documentation, and sometimes there's a mixed.
Yes. Absolutely. Yeah.
So, and my question was, are you moving also from a pure data centric approach to something which is more in between and yes, always based on systems modeling, but also making the link with tradition about documents models.
Yes. So we will have a way to connect to the breakdown of documents.
Yes.
Yes. So So in that sense, the answer is yes. But the models that we want to make are they're not about documents. So
No, but it's part.
But this transition means that in a transition period, you definitely will need the documents. But at some stage, hopefully, you will be able to build the trust that the information in some documents are in the model, and then the need for document will vanish. But there will always be a need for that kind of documentation that you mentioned, and maybe that could also be implemented as a view of the model. So I mean, you could foresee that the PNID is a query to the model. So yeah.
If there are no other questions, we can end up this session. Very good. Thank you. Thank you very much.